Hopefully you're all with me on page 511. Have any of you ever worked with your parents, your dads, on roofs or building or cutting or anything of that sort? Oh, man. A couple of you. Or the men in your life. Okay. Then, have any of you ever been in your own attic? Yeah. If you are inside your attic and you look at the framework above you, you will see this top portion of the roof that's on page 511. Okay? You'll see that. And what they share with you in that little construction paragraph is the fact that the wood that is placed within the framework of the roof is in there to brace for the weight above it. Okay? They call those things trusses. Anyways, the point of this leads us into talking about triangles. So, don't be scared, but let's look at example 1. And I'm going to click record here. We'll get started. I already have. Good. Example 1. Classifying a triangle by angle measures. Everybody sees that? Okay, so angle measures. What are the 3 different ways we might describe a triangle by angle? Any ideas? Angle.
Acute.
Acute. And? Right. Okay. So if there is a right angle, a 90-degree angle, you will call that triangle right. Okay? If there is an obtuse angle, so that would be greater than 90 degrees, you will call it obtuse. If neither of these is within that triangle, then all of your angles must be acute, and then you would name it acute. You guys are also familiar with naming a triangle based on side lengths, right? You've got equilateral, scalene, and what's the other one? Isosceles. Good. Isosceles. Okay, but we are talking angle measurements here in example 1. Okay, we're talking angle measurements here in example 1. Don't let all of those tiny triangles scare you. Look at what they are giving you. Measure of angle DBE is 64 degrees. DBE, 64 degrees. So that is the triangle. So within the sketch, I'm going to just quickly kind of sketch it.
It reminds me of how many triangles you can find.
All right. D-B-E. I'm not sketching the whole thing. I only care about part of this. So within that, they have sketch DBE. The measure of angle DBE is 64. So that's this, DBE, right? 64 degrees. Everybody with me on this? And they also tell us that BDE and BED are the same. BDE and BED are the same. So those two that I just kind of colored in yellow, those are the same. Classify BDE by its angle measures. Okay, in order to do that, I actually have to have the angle measures, don't I? I can guess right now. I think it's going to be acute, but I'm not going to do that. I'm going to actually discover for sure. So how might I figure out if this triangle is indeed acute? Go ahead, Haley.
Have 180 subtract 64 from that and divide your answer by 2.
She's right. What she said was, you know that all 3 angles is going to equal 180, right? And you already know one of them is 64. Right? If you remove that 64 degrees from the 180 and you're left with 116, you know that those 2 angles share 116 evenly. Dividing by 2, and Ethan came up with 58. It would look something like this. The 64 degree angle that I know added to the other angles must equal 180. Subtracting the 64 and combining your x's, you come up with the total that remains. Dividing by 64, and you get the value of those 2 yellow angles, which is 58 degrees. So now I know I have a 64 I have a 58, and I have another 58. So far, so good? Since, is there a right angle in this mess?
No.
Is there one that's obtuse?
No.
Therefore, to classify it by its sides, it has to be acute, right? It's an acute angle. Any questions on this? Checkpoint number 1 has you doing the exact same thing. Okay, let's do checkpoint 1. Everybody got me? Everybody's writing it down? Okay, checkpoint 1. Similar diagram. Given that the angle of EDG is 38, so that's this next triangle here. Awesome. Okay, so I'm using the same sketch. And what they've just told me is EDG is 38. Well, I've got to draw it, folks. That's this, and that is 38 degrees. And the measure of DGE is 38 more than the other. And the measure of DEG is 38 more than the other. So this one here and this one here are different. Okay? This one is 30 more than that one. Right? So far, so good? Okay. So there's my drawing. How can I write this out so I can actually solve this thing? Well, go ahead. What were you going to suggest?
Take 180 minus 38.
Okay, hold on. What do you get?
142.
142. So now I know that I have two angles sharing 142, right?
Yes.
So what would you do next?
You divide them by 2.
Mm-hmm.
And then, so you get 71. Then you subtract 15 from G and add it onto E.
Okay, and what did you get?
56 is G.
Okay.
86 is E.
Close. Oh, so close. Yes, ma'am.
What I did is I did the first step. I came out with 142. I subtracted 38, and then I divided the remaining numbers by 2.
Yep.
And I got 52 and 90.
Okay, you were so close. You have to first subtract out the 38, or which one's bigger? 38 more, yes. You have to first subtract out what's bigger, that bigger amount. And now you have 2x equals, what's 142 minus 38, Haley?
104.
104. So divide it, 52, okay? So one of them is going to be 52. The one that's x plus 38 is going to be 90, okay? So far, so good?
Yes.
So I've got a 38, I've got a 52, and I've got a 90. The questions, is there a 90 in this mess?
Yes.
That makes it
Right.
Right, bravo. Okay, I think you've gathered it. Moving on. We're on page 512 now, finding unknown side lengths. 512. The perimeter of a scalene triangle is 65 centimeters. So if a triangle is scalene, what do I know about the sides? They're all what?
They're different.
They're all different. They're all different. Scalene means they're all different. So they're saying the perimeter of a scalene triangle is 65 centimeters. So side plus side is 65. Okay? 65. Side plus side is 65. What do we know? The length of the first side is twice the length of the second side. So to sketch this, the first side is twice the length of the second side. So here's length, and here's length, and this one's double that. Would you agree? The length of one side is twice the length of the other. And the third side in question is 20, right? Adding them together, you're going to have L plus 2L plus 20 is 65. Working it, you're going to get 3L plus 20. And then when you subtract your 20, you get 3L. And when you divide, 15. So that means the first side is what?
15.
And the second side is?
30.
30. Now let me ask you this. What if you came up with 10 here? 2 times 10 is 20. How do you know you're wrong?
You're off by another 10.
Huh? Okay, number one, it doesn't add up to 65. Let's say you added it together and you came up with 65. How can you still know you're wrong? What kind of triangle is it? Scalene. Right. That's okay. Scalene. So if you have two sides that are the same, you already know you're wrong because you can't have two sides that are the same in a scalene triangle. Okay? So Ethan says first add them up, you better have 65. And if for some strange reason you did come up with 65, but noticed you had two of the same sides, something else is wrong. Okay? Rethink your question. All right. Finding angle measures using a ratio. All right. Example 3. The ratios of the angle measures of a triangle is 1 to 3 to 5. Find the angle measures, then classify it by its angle measures. 2 parts here. Don't just tell me the angle measures, because if you do, you're going to get half the problem wrong. So again, I'm going to draw something here. I don't know how much it is, but I know that this is 1, this is 3, this is 5 by ratio. Okay? By ratio, this is 1, this, and I'm just kind of using this to picture it. Okay? 1 to 3 to 5, I kind of labeled it like it was sides. Let X represent the value of the measures. So I know the smallest one is X. The next size up one is triple the little one. The largest one is 5 times that of the big one. By multiplying each one by the corresponding ratio number, I have now made one smaller, one medium, one bigger. What's the total going to be, by the way, of these 3 angle measures?
180.
180, bravo. So that means 9x is 180. So x has to be 20, right? So the one that's 1x is how many degrees? 20. The one that's 3x is how many degrees? And the one that's 5x?
100.
How do I know that I'm right?
Scaling.
It all adds up to 180, first of all. The other thing is if you took these numbers, 20 to 60 to 100, and compared them to 1 to 3 to 5, you would find that this forms a 1 to 3 ratio. You would find those numbers form a 3 to 5 ratio, and you would also find that those numbers form a 1 to 5 ratio. Okay? So you know you've got your numbers correct. How are you guys feeling about this?
Easy.
Not too shabby, right guys? All right. Would you guys like to do another sample like this, or do you feel good?
Good.
Kat? You want to do another sample? One more sample is what we're going to do, and it's just like example 3, okay, folks? Checkpoint. Bottom of the page. The ratio of the angle measures of a triangle is 3 to 5 to 12. Find the angle measures. Same thing, okay? Only the smallest is a 3x, medium, large. Altogether, there's still 180, okay? Altogether, there's still 180. Adding up all your x's, you get what, 20x? Divide it out, x is what? 9, okay. 3 times 9 is what? 5 times 9 is 45. 12 times 9 is 72. Here's your angles. You've got 27, 45, and 72. What kind of triangle is this?
Obtuse.
Obtuse? Doesn't have anything bigger than 90. Acute. I didn't label this one. What kind of triangle is this one? Obtuse. Okay. I didn't listen to my own information there. Make sure you tell it by sides or by angles. All right. I'll give you guys the rest of your